But in this question, they have rather given us the equation of the tangent. So we are rather to find the coordinate of the point of contact of the circle. So this is our circle, and we have a tangent drawn to the circle, and the tangent touches the circle at this point. The equation of the tangent is 2x plus 3y is equal to 13. And the equation of the circle is x squared plus y squared is equal to 13. What I want to determine is the coordinate of the point of contact. Previously, they would have given us the coordinate of the point of contact, and we will have found the equation of the tangent, but now the equation of the tangent has been provided. Good. At the point of contact, the coordinate or solution to this is so to identify this coordinate, we'll solve these two equations simultaneously. Yes, Papaya.
Sir, does that mean that the first equation is the equation of the circle?
Yes.
Okay.
The first equation is the equation of the circle.
Okay.
Good. So if you take, if you can recall, this is an equation of the circle with center. Who can tell me the center, the coordinate to the center? Yes, and I am 0, 0. So that is how the equation of a circle whose center is 0, 0 look like. It's always x squared plus y squared is equal to some number. Good. So this is a circle with its center at the origin. So the point of contact will be the simultaneous solution of their equation. So let's solve the two equations simultaneously. So our first equation is x squared plus y squared is equal to 13. That's the first equation. And the second equation is the equation of the tangent. 2x plus 3y is equal to 13. Second equation. Good. So what we will do is to make y the subject in any of the equation, but it is better you make one of the variable the subject in equation 2. If we make one of the variable the subject in equation 1, the equation will look more, the expression will look more cumbersome to handle. Let's make x a subject. 2x will be equal to 13 minus 3y. And then our x will be equal to 13 minus 3y on 2. Then we substitute this into equation 1. So wherever we see x, we write this fraction. So we have 13 minus 3y all on 2 squared. Then plus y squared is equal to 13. Then what it means is that the square is affecting the top and the square will also affect the down, which will give us 4. Plus y squared is equal to 13. Okay, so the form will expand. Why is that people can still not join directly or have not opened the meeting? Let me see. The meeting is also open. Okay. let's proceed. So we are going to use the Pascal triangle to expand this bracket. If you cannot use the Pascal triangle, then you can expand this step by step. Okay. So by the Pascal triangle, we'll square the 13, and that is 169. Then multiply 13 by 3, and that will give us 39, minus 39. We are multiplying by negative 3, so that will give us minus 39. Then we'll multiply it by 2. So 39 times 2, let me quickly check. That is 78. So minus 78y. Then we square the minus 3y. And that will give us positive 9y squared all over 4. Then plus y squared is equal to 13. Good. We'll clear fraction by multiplying through by 4. So 169 minus 78y plus 9y squared plus 4y squared is equal to 13 times 4. Let's quickly check that. It is 52. Good. So this is a quadratic equation in y. So we arrange as such. We add the y squares. And that will give us 13y squared. Then minus 78y. Then we have 169. Then we bring the 52 to the other side to come and subtract. Okay. So let's perform the subtracting. 169 minus 52. That's 177. So we have 13 y squared 78y plus 117. We'll check whether a number can divide through, so that will simplify the expression a little bit further. So 13 can divide through. Let me be sure. Let me see, 78 divided by 13. Yes, it can divide through. So let's divide through by 13. So 13 y squared divided by 13 will give us y squared. Then the negative 78 divided by 13 will give us 6. So we'll have 6y. And then 117 divided by 13 will also give us 9. It's equal to 0. Then we'll factorize this expression. We are looking for two numbers. When you multiply, you get 9. When you add those two numbers, you get negative 6. And the numbers are negative 3, negative 3. Negative 3 times negative 3 will give us positive 9. 3y minus 3y plus 9 is equal to 0. The first two terms, we can take y out, and we are left with y minus 3. And then the next two terms, we can also take minus 3 out, and we're left with y minus 3 is equal to 0. We complete our factorization. So it is y minus 3 is equal to 0. So it implies y minus 3 is equal to 0 and y is equal to 3. So the coordinate of y is 3. Then we'll come back and then solve for x using the change of subject we did here. So we said x.
Go back to your lecture.
Yes.
Yeah. So you can go on. You can go on.
Okay, x is equal to 13 minus 3y. 13 minus 3y on 2. So we know our y, which is 3. So 13 minus 3 multiplying 3, or on 2. So x will be equal to 13 minus 9, all on 2. So our x will be equal to 13 minus 9 will give us 4 on 2. So the x coordinate will be 2. So the point of contact is 2, 3. So that's all for this question. Any question?
Sir, please, can you
Roxanne,
please move to the previous slide? Sir, please, can you move to the previous slide? Okay, thank you.
any other question or concern? Let's look at this question. Given the circle x minus 2 all squared plus y plus 1 all squared is equal to 10. Find the equation of the tangent at the point 4, 1. Show that this tangent is perpendicular to the radius at the point. So we have 3 questions. Good. So this is our circle. And the tangent is drawn to this circle. And the coordinate at the point of contact this time around is given is 4, 1. And the question says we should find the equation of the tangent at the point 4, 1. Good. What is the center of the circle? Hello? What's the coordinate of the center? Are you? If IU is not ready, let's go to Roxanne. Okay, Clifford.
So you said the center of the circle, right? So
Yeah.
2, -1.
2, -1 is correct. So the equation of this circle has been written in the standard form. The standard form of the equation of the circle is x minus a all squared plus y minus b all squared is equal to r squared, where a comma b is the center. So the equation of this circle is written in the standard form. When an equation is written in the standard form, it's very, very easy to pick out the coordinate of the center, unlike the general form, where plus C. This one, you can pick the coordinate directly. So here, comparing, it will mean that our minus A here is equal to -2. Our minus A in this bracket here is equal to the -2 here. So it means our A will be +2. Then comparing, our minus B will be equal to the 1 here. So minus B is equal to 1 implies B is equal to -1. So the center will be 2, -1 as rightly indicated. Good. So we are looking for the equation of the tangent. First and foremost, we'll determine the gradient here, and that gradient is always perpendicular to the tangent. So the negative reciprocal of that gradient will be that of the tangent. So let's calculate the gradient. And this line that I've just drawn is the normal. So gradient of normal. And this will be equal to, we know it's y2 minus y1 all over s2 minus s1. So let's call here s1, y1, and s2, y2. So substituting, we'll have 4 minus 2, sorry, those are the s coordinates rather. So we have y minus -1 on 4 minus 2. We are going to get 2 for the top, 2 for the down, and this will yield 1. So that's the gradient of the normal. Then the gradient of the tangent will be the negative reciprocal of that. So gradient of tangent is the negative reciprocal of 1. And that will give us what? -1. Good. So now we are going to calculate the equation of the tangent using the coordinates 4, 1, because that's where the tangent passes. And we are going to use the formula m standing for gradient s minus x1 is equal to y minus y1. So we have -1 x minus 4 is equal to y minus, the coordinate is 4, 1, so -1. Okay, so open the bracket, we have minus x plus 4 is equal to y minus 1. Collecting like terms, we have 4 plus 1 is equal to y. So the equation is y is equal to 5 minus x, or x minus x plus 5, whichever way you want to write it. That will be the equation of the tangent. Any question? Second question. Show that this tangent is perpendicular to the radius at that point. Good. Yes, Charles.
Please, won't the equation of the circle be y is equal to x minus 5?
Let's go back and check. Is it x minus 5?
Yes, sir.
Why x minus 5? Why x minus 5? Because the x is rather negative here, and the 5 is
About chance.
rather positive.
Okay, sir.
But then, so that's the B. The gradient of the normal is the same as the gradient of the radius. The reason being that if you look at the yellow line, which I said is the normal to the circle, it equally is the rest of the circle. The normal to the circle always can be extended beyond bound. We can extend it at both ends. But the radius begins from the center to the circumference. But they have the same gradient, because gradient talks about how steep or the slope of a line. Since the normal is superimposed, it's just in line with the radius. They will have the same gradient. So the gradient of the radius is exactly that of the gradient of the normal. And we have to show that the tangent is perpendicular to the radius at that point. To show this, we have to show that the product of the other. So let's gradient of radius be m1, and then gradient of tangent be m2. If m1 times m2 is equal to -1, then they are perpendicular. And what is our m1? m12 is equal to 1, and m2 we saw it as -1. So 1 times -1 is indeed equal to -1. Therefore, the radius is perpendicular to the tangent. Any question about that?
Sir, please, can you go back? I want to check something to the previous slide.
We are there.
Sir, please, okay, thank you.
Okay. Yeah. Are you? Are you Samuel? Your hand is up. Are you? I can't hear you. Akosi Ahinewa.
Sir, please, don't we just go straight forward and use the gradients, the normal gradient, to find the equation of the normal?
What we found was the equation of the tangent, not the equation of a normal.
So no, you see, we first found the gradient, then we
Good.
did a
Yeah, to be
negative
one.
reciprocal of the gradient to find the
Yeah.
tangent. So why don't we just use the
Mhm.
first gradient to find the normal?
Yes, that would have given us the equation of the normal, not the equation of the tangent, but we are after the equation of the tangent.
Okay.
So if they requested us to find the equation of the normal, then we would have used the positive one because that represents the gradient of the normal. But because we are after the equation of the tangent, then we have to use the gradient of the tangent, which will be a negative reciprocal of that of the normal.
Okay, thank you.
Welcome, madam. Any other? Okay, so that is a B part of our question. Let's go back and see whether we have other questions. Yes. We have to find the equation of the normal and show that it passes through the center. So the one who just asked the question. So this is where we'll use the one. We'll use the one. So let's find the equation of the normal. Normal. The gradient is equal to 1 and it passes through the point 4, 1 at the point of tangency. So these are the information we'll use. So here we have 1 for the gradient multiplying s minus 4 is equal to y minus 1. We'll have x minus 4 is equal to y minus 1. And then we have x minus 4 plus 1 is equal to y. Implies our y is equal to x minus 3. So that's the equation of the normal. The equation of the normal. Then it says that we should show that it satisfies, or it passes through the center, and the center is 2, neg 1. And this is how we can show that if the normal passes through the center, the center is 2, neg 1, then the coordinates must satisfy the equation. The coordinate must satisfy the equation. So let's see whether the coordinate really satisfies. The equation is y is equal to x minus 3, and the coordinate is 2, neg 1. So place the neg 1 in place of the y. Then we'll put the 2 here, and then we simplify and see whether our left-hand side will be equal to our right-hand side. So we have -1 is equal to -1, which is a true statement in math. Then we can conclude that since 2-1 satisfies the equation, it means it passes through the center. For instance, just by the way, the tangent which doesn't pass through the center, that one we had an equation to be y is equal to 5 minus x. If we substitute these values, you have -1 is equal to 5 minus 3. Sorry, 2. The x is 2. You have -1 is equal to 3. This is a false statement. It's false statement because -1 is not equal to 3. So we can see that the center does not satisfy the equation of the tangent. This implies the tangent does not pass through the center. That is not a requirement of the question. I just want you to understand. Any question? Teresa.
Sir, please, I didn't get the B part well.
Okay, the B part, it says that we should find the equation of the normal. After finding the equation of the normal, we should show that the normal passes through the center of the circle. So to find the equation of the normal, we need the gradient of the normal. And the gradient is 1. I've written that in the bracket over there. And the normal passes through the point 41. So we substitute this into the equation of a line formula. Then this is the equation we obtain. Then we have to prove that the normal passes through the center. If it passes through the center, then the coordinate of the center must satisfy the equation we have gotten. If the normal passes through the center 2-1, then the coordinate must satisfy the equation. The equation we just got, that is y is equal to x minus 3. Good.
Yeah.
So on the next page, we place in the values of the coordinates. Remember, when you have a coordinate system, the first letter is for the x and the second letter is for the y. So we just place the y component here. Then we place the x component at its position. So when we simplified, we saw that the statement that stated that -1 is equal to -1. In mathematics, that statement is a true statement. -1 is indeed equal to -1. Or the left-hand side is indeed equal to the right-hand side. So it means the coordinate 2-1 indeed satisfy the equation of the normal. Y is equal to x minus 3. Once a point satisfies an equation, it means the point is on the line. Maybe I know what they call that. So the blue one is just to test, just to give you a juxtaposition of why this is valid. So this time around, the blue one, I use the equation of the tangent. It is not part of the requirement of the question. This is just to juxtapose our solution so that you can have a better picture. So y is equal to 5x, 5 minus x. So when you throw in the values, that is the 2 neg 1. So -1 for the y, then 2 for x. We simplified it and we got -1 is equal to 3. And in mathematics, we all know that -1 and 3 are not equal. So that is a false statement. So it means the point 2 neg 1 cannot satisfy the equation of the tangent. And hence, the tangent does not pass through the point 2 neg 1, which is the center of the circle. Is that okay, madam? The one who asked the question, are you okay? That is okay. I've seen a thumbs up. Okay, good. So that is the end of that question. Let's look at yet another one. Find the equation of a tangent to the circle that are parallel to the line 3x minus 2y plus 5 is equal to 0. So find the equation of the tangents. Find the points of contact so that the midpoint of the points of contact lies on the straight line and determine its equation. Good. So let's draw our circle. So there's a circle. So the equation of the circle is the first one. And then we are being told that the tangent to the circle is parallel to a given line. So this is the tangent. Let me draw the tangent well. This is a tangent. But there's another line somewhere here that is parallel to this tangent. So these two lines are parallel. Meanwhile, this equation does not belong to the tangent, it belongs to this line. 3x minus 2y plus 5 is equal to 0. Good. So this line is parallel to our tangent, but we don't know the equation of the tangent. I will know the equation of the line that is parallel to it. Good. So now let's try to see how best we can find the equation of the tangent and then find the point of contact. And then show that the midpoint of the point of contact lies on a straight line and determine its equation. Good. First and foremost, let's find the center of this circle. Yes, what is the coordinate of the center? Who can tell me? Yes. Clifford, Agbesi.
0, 0.
Good. So the coordinate of the center is 0, 0. This is not the first time. Say when you see an equation in this form, x squared plus y squared is equal to 13, the center is 0, 0, because if we want to express this in the standard form, that will be x minus 0 all squared plus y minus 0 all squared. And that will give us the 13. Good. What will be the radius? Clifford again.
Sir, please, the radius is root 13.
Good. The radius is root 13. Very good. The radius is root 13. It's all coming from the fact that we can express this and compare it to the standard form for the equation of a circle. In the standard form, we have x minus a. Let me write that. X minus a all squared plus y minus b all squared is equal to what? R squared. So this implies our a is 0, as we've already said. Our b is also 0, as we've already said. Then our r squared will be equal to 13. It implies our r is the square root of 13. Good. I heard a sound like somebody raising up their hand. Or it's not a question.
Yes, please.
Okay. Okay, so let's proceed. Now, to find the equation of the tangent, we have to go to back to our first year coordinate geometry. Good. First year coordinate geometry. In coordinate geometry, we have the standard form for the equation of a circle. A line. Like how we have the standard form for the equation of a circle, we also have the standard form for equation of a line. And that is ax plus by plus c is equal to 0. So like this one, it is already in the standard form. So our equation of the tangent, we can express it in that form, plus by plus c is equal to 0. Good. So we need to determine a, b, and c. That is all that we need to do. Good. So let's go to the next page. Since the tangent is parallel to 3x minus 2y plus 5 is equal to 0. Its equation will be of the form 3x minus 2y plus some constant c is equal to 0. What it means is that when a line is parallel to another line, the only difference between their equation is the constant term here. The y coordinate, the y coefficient and the x coefficient will all be the same. The reason is that is you see, when two lines are the same, they are related to the same. And you can by the coefficient of the x and y. For example, if I want to write this one, let me even write the equation, the tangent equation, ax plus by plus c is equal to 0. And then write this one as 3x minus 2y plus 5 is equal to 0. If we want to express this one in the y, the gradient intercept form, you have by is equal to c minus ax. Then later on we divide through by b. So c over b, then minus ax over b. Then this one too, when we want to write it in the gradient intercept form, the minus 2y will be equal to, so here should have minus c, because all of them are crossing the equal sign. So we have minus 5, then minus 3x. Then you divide through by negative 2, you have minus 5 over negative 2, then minus 3 over negative 2x, or otherwise y is equal to 5 on 2 plus 3 over 2x. Good. We know that in the gradient intercept form, this is the gradient of the line. And here too, this is the gradient of the line. And since they are parallel, they should be equal. So if I have something like this, minus a over b is equal to 3 over 2, in mathematics, the only way this fraction could be equal, when in their simplest form, the only way they can be equal in their simplest form is when the a is equal to the 3, the top is equal to top, and down is equal to down. So you see, at the end of the day, our tangent will still have these values as the coefficient of x and y. What will differ is the c. So I say another line is parallel to it, and the line is written in the standard form. Then the line that is parallel to it is likely to also pick the form whereby the coefficient of the x and the coefficient of the y will all be the same, except the constant term there. Good. So that is that. That is from coordinate geometry 1 in SHS 1. So at least we have identified our A, B, left with the C. That will identify, and we are good to go. Good. Now, the distance between here, the center, and the line is the radius of the circle. Is the radius of the circle. And that is also the perpendicular distance between the center and the line. Perpendicular distance between the center and the line. And we have a formula for calculating the perpendicular distance between a center and a given line. That formula is from coordinate geometry 1 in SHS 1. Perpendicular distance of the center to the tangent. The formula is, or in SHS 1, that heading will be titled as the perpendicular distance between a point and a line. So come here. So that's the concept that we are applying. It was mentioned maybe in SHS 1, but they didn't specifically say it's the center of a circle or whatever it is. They gave the formula in its more general form, that if you have a line drawn like this and you have any external point on the line, let's call it S0, Y0, you can actually compute the perpendicular distance between the line and that particular point if you know the equation of the line. So that is the idea we are extending here. So that formula I'm coming to give you is the more generic, robust form or formula that can be used in diverse situations. So when you also come here, this is a line and this is an external point. And that external point coincidentally happens to be the center of the circle. Good. So we are going to use that formula to solve for our equation of the circle. And the formula is a x naught plus by naught plus c in absolute terms. The bars here means in absolute terms. It means when you get -1, you make it positive over the square root of a squared plus b squared. So that's the formula. Where our x naught, y naught is the point. X naught, y naught is the point. And in this case, that is the center, which is 0, 0. So let's fix in the values. Our a value here, the ABC is picked from the equation, the standard form for the equation of a circle. Sorry, of a line, the standard form for the equation of a line. So our a is 3, then our x naught is 0. So 3 multiplying 0 plus b, which is also -2, -2 also multiplying 0, plus our c. Sorry, I should have written here, we are using the tangent, not this line. So ax plus by plus c. Okay. And the c we don't know yet. That's what we are yet to find. Yeah. Then over 3 squared, then plus -2 squared is equal to that distance that we are looking for is actually the radius. So we can equate it to what? The square root of 13. So let's continue solving. The top, the 0, 0, 0 all drop. So we have absolute 13, absolute c, sorry, absolute c left because we have 0, 0 over the square root of, we have 9 plus 4, and that will give us 13 is equal to the square root of 13. Then we multiply by root 13, then we'll get 13. It means our c is equal to either positive 13 or negative 13 when you remove the absolute sign. Good. Why it is negative 13 or positive 13? It's because of the absolute sign. We said we could have, if you make, the absolute sign means that if I have 5, the answer is 5. Absolute 5 means 5. And absolute -5 also means 5. Absolute means that we are looking for the value of the number regardless of what? The sign. So if I have absolute c is equal to 13, that means -13 can satisfy the equation and 13 too can satisfy the equation. So if you are looking for numbers that can satisfy this equation, that is 13 and -13. So the equation of the tangent, so the tangent is, we are going to have two equations. We have 3x minus 2y plus 13 is equal to 0, and 3x minus 2y minus 13 is equal to 0. And no wonder the question was emphasizing that we should find the tangents with an S, tangent, because they are possible, two possible tangents. So when you come to the diagram, it means that there can be another tangent over here, which is also parallel to this line. So these are the two tangents the question is talking about. So there's one here, there's one there, all of them parallel to this line over here. It is 1 minute to time. So let's end here. We'll meet next week and then look at some wonderful questions under this section. Some wonderful questions. So let me give you your attendance very quickly so that you mark and then you leave and join other classes. And the attendance word is build. It's on the screen now. So you can mark to build something, to build a house. That's the attendant word, build. So quickly mark and then join other classes. Quickly mark and join other classes. Good.
Sir,
Yes.